All right, so I think I'm recording. Let's take a look. We're looking at Skill Packet 5, exponential and logarithmic functions, and in this homework in Skill 5G Day 1, we are solving equations, and some of these equations cannot be written with the same base like we did before, so we have to use properties of logarithms to solve some of these. If I look at problem 7, on the left hand side I see two terms, on the right hand side just a constant. Well, the variable of interest is in this first term. So the first thing I need to do is isolate that first term because it has my variable of interest. So I need to subtract 9 from each side. All right, so now on the left-hand side I have two factors. I have this number 5, and then I have this number e to the x plus 4. And it's the second factor that contains my variable. I need to get it by itself, so I need to divide both sides of this equation by 5. Now, you're probably not going to like it too much that the 5 divided by 5 is 1, but I just need to leave this as an improper fraction because it's not like it's 10 divided by 5, which is 2, but I'm just going to leave it as this number. Now I've gone as far as I can go with getting the variable by itself, and I'm going to have to now use the idea that this exponential equation has an inverse of a log function. I need to take the natural log of each side of this equation. I'm choosing the natural log over the common log because this base is e, so it's convenient for me to take the log base e of each side. So rather, we know that the ln, the natural log, has a base of e, but for right now, when I take the base of e, I'm just going to write, or when I take the natural log, I'm just going to write it as log base e to kind of help you visually see that the justification for that is because now these have the same base. So I can now argue one of two ways that because these are inverses that I just get this x plus 4, or by the power rule I can pull the x plus 4 down out in front, and I know the e to the first power is e. So there's multiple ways to argue that this simplifies to x plus 4. All right, so now we've almost got the x by itself now. I need to get rid of this other term, subtracting 4 from each side. So I have x is equal to this negative 4 plus log base e of this fraction. Now you're not going to ever see in majority of textbooks, at least in the United States, that this written as log base e. What you are going to see it written as is the natural log. I always write it in cursive because if I write ln, so many people think this is an I, so that's why I write the ln in cursive. It's really just out of habit. I do it without thinking about it. It's just the other day I saw people telling me IN, and I thought, what's IN? And then I recognized that in type that they thought that they didn't recognize that it was an L. They thought the lowercase l was an I. So anyway, this is my final answer. Um, yes. Okay. Now let's go ahead and take a look at number 8. Um, on the left-hand side, I have two logs, and they both have the same base, e. I have a property of logarithms that say if you have the sum of two logs, you can write it as a single logarithm. So I can condense these two terms to one term by just taking x and multiplying it times the 3x minus 2. So now I need to I'm trying to get x by itself, but I've gone as far as I can go with this in logarithmic form. Remember that this is a base of e. I can change the form um, and recognize that this log form can be changed to exponential form by just saying e to the first power is equal to, because remember the base, the logarithm equals the exponent, is equal to 3x squared minus 2x. So this is a quadratic equation, and you may not be a fan of this problem. For quadratic equations, we hope that we can factor it, but a lot of times you can't. So we've got 3x squared minus 2x minus e. And now remember that e is not a variable. That e is a number. That it's approximately 2.718, and it goes on. So I can't factor this, but I can use the quadratic formula. I can identify that the coefficient in front of my squared term is 3, in front of my linear term is -2, and my constant is negative e. So I can use the quadratic formula. You're not going to like it probably very much, but here it is. The quadratic formula tells us a solution to this quadratic equation by taking the opposite of b. Well, if b is -2, the opposite of -2 is +2. We have two solutions, but because of the symmetry involved, we can write plus and minus is the square root of b squared. Well, -2 squared is +4, minus 4 times a, which is 3, times c, which is this negative e. All right. Now, the denominator is 2 times a, so I have 2 times 3. So let's see if we can't simplify this. So I'm going to give myself a little bit of room by shrinking things up, getting this out of my way, moving this up. So I have my answers, or my potential answers, because remember, I'm concerned that I can't take the log of a negative number. I just need to simplify this and really then plug it in a calculator and get a decimal approximation. So I've got 4, and this guy simplifies to 12e. And then I've got 6 here. Well, I notice that this binomial, that 4 divides both of those. And the only reason that I'm interested in factoring that out is because now I have a property of radicals that says if you have a product that you can take the square root of the individual factors. Okay, so why is that helpful? Well, because the common factor was a perfect square. So I have this numerator that has a first term of 2, and in the second term I can break apart this multiplication. I can take the square root of 4, which is 2, but I can't really simplify the square root of 1 plus 3e. So now I look and I see, well, hey, in the numerator both of these terms are even, and 6 can be rewritten as 2 times 3, so I've got common factors there that divide to 1. So I have my possible answers of 1 plus or minus 1 plus the square root of 1 plus 3e divided by 3. If I don't even know if I said that right. Now, let's get this value of x with the calculator, decimal approximation. Well, 2 values. So we've got our calculator right now set on 3 decimals, and that should be fine for right now. Now, I need parentheses around my numerator, and I'm going to do the subtraction first. So I've got 1 minus the square root of 1 plus 3 times e. And I don't know how to get just an e, so I'm telling e to the first power. So there's my numerator, 1 minus the square root of this guy. Now my denominator is 3. So that is a negative number, okay? And when I look to these terms here, I have the natural log of x. Well, I can't take the log of a negative number, so I know that's extraneous. So let's come back to my expression here. Change this to positive. Now, my other possible solution of 1.342. Now, although that's positive, remember we have this 3x minus 2. So I need to take 3 times my previous answer that was just that one. Whoops. 3 times my old answer. That's, well, I'm trying to hit the buttons, but it's not cooperating. There you go. My previous answer is what, and actually the calculator internally will carry that out to more than 3 decimals. And then I've got minus 2. Now I need this to be a positive value, or I'm going to have to call it extraneous. It is a positive value, and I know that the natural log of this so this is my answer, my approximation of my answer to 3. This was my exact answer, except that I decided I knew to throw out the negative sign. So here's my exact answer, and here's that decimal approximation of that exact answer, and I hope that helps.